In the last video, we have seen some examples of tangent and normal. Let us see some more examples from the same topic, tangent and normal. Here is the next example. If the curve y is equal to ax square minus 6x plus b passes through the point 0, 2 and its tangent at x is equal to 3 by 2 is parallel to the x-axis, find the values of a and b. This curve passes through this point. This is not point of contact, remember. For the point of contact, value of x coordinate is given 3 by 2. So, looking at the example, we can decide that if I put x is equal to 0, y is equal to 2, in this equation, I will get one equation in a and b, and one more, I will differentiate this with respect to x. That is dy by dx will I get. Then dy by dx at x is equal to 3 by 2. Tangent at this point is there. So I will get slope, and since the tangent is parallel to x-axis, so slope of that tangent will be 0. So let us come to this example. We will solve this. Consider this given curve y is equal to ax square minus 6x plus b. This is our equation number 1 as usual. Since this curve passes through the point 0, 2, 1 passes through which point? Through the point 0, 2. Means at this point x is equal to 0 and y coordinate is equal to 2. This point will satisfy this equation. So I will put these values, x is equal to 0 and y is equal to 2 in equation 1. What will I get? Y is equal to 2. Therefore 2 is equal to a into x is 0, x coordinate is 0, minus 6 times again 0 plus b. So what will I get? Look at this, 0, 0, and here remains only b. So what is value of b? B is equal to 2. Look at these values, this will become 0, this will become 0. So b is equal to 2. Thus I get the value of b. Now come to this equation. Tangent is there, so our steps are there. Can you remind those steps? Yes, first step to find different derivative dy by dx. So let us differentiate equation 1. Now differentiate this equation 1 with respect to x. Differentiate this equation with respect to x. So what will you get here? Differentiating this equation with respect to x, dy by dx is equal to ax square, its derivative with respect to x. Look at this, a is coefficient, constant is there, x square. So what is derivative of x square? It is 2 into x. So it is 2ax minus 6 into x. Derivative of x is 1. So there is minus 6 only. And b is only constant, so its derivative will be 0. Derivative of b will be 0. So here I get this equation, dy by dx is equal to 2ax minus 6. This is derivative of y with respect to x, and this will give me slope of tangent at the point x is equal to 3 by 2 if I put x is equal to 3 by 2. Right? So my second step to find value of this derivative at that point of contact. Therefore dy by dx at the point of contact x is equal to 3 by 2 is equal to 2a into bracket 3 by 2 minus 6. This is nothing but 2 will get cancelled. So this is a into 3a minus 6. Therefore dy by dx, value of the derivative at x is equal to 3 by 2 is nothing but 3a minus 6. This will give me slope of tangent at this point of contact. But one more information is given there. What is that information? The tangent is parallel to x-axis. Do you know when line is parallel to x-axis, what is its slope? What is the slope of that line when it is parallel to x-axis? Yes, slope of the line will be 0. Slope of x-axis is 0. Therefore, slope of tangent which is parallel to x-axis is equals to 0, which is slope of tangent, slope m of the tangent. But what happens? But this tangent is parallel to what? X-axis. Tangent is parallel to x-axis, and hence slope of the tangent, therefore m is equal to 0. So I will equate this value to 0. M is equal to 0, and this is nothing but m. 3a minus 6 is equal to m. You can see here that is equals to m. Okay, so m is equal to 0, and hence what will you get? Can you solve the next part, remaining part? 3a minus 6 is equal to 0, means a is equal to 2. So value of a, therefore I will write here. Can you see this part? 3a minus 6 is equal to 0, and this implies a is equal to, look at this, 3a minus 6 on that side will be plus 6. 3a is equal to 6, and therefore a is equal to 6 upon 3, that is nothing but 2. So what are the values of a and b? Yes, a is equal to 2 and b is also equals to 2. Let us go to the next example. Find coordinates of the point on the curve y is equal to x log of x, at which the normal is parallel to the line 2x minus 2y is equal to 3. We have to find coordinates of the point on this curve y is equal to x log x, at which the normal is parallel to the line 2x minus 2y is equal to 3. So what is the given curve? Given curve is y is equal to x log x. Because of the space we have to solve is little small letters, so adjust it. We are not in our classrooms, therefore we have to adjust this. Okay, so y is equal to x log x is our curve. This is nothing but our equation number 1. Now look at this. On this curve there is a point through which we have to draw the normal, and that normal is parallel to this line. Okay, so and normal to the curve 1 is parallel to the line given by this equation 2x minus 2y is equal to 3. So using this line we will find slope of normal. Normal is parallel to this line, so slope of this line will be slope of our normal. Therefore slope of normal is equal to slope of the line 2, equation number 2, it represents that line, and that slope is equal to, we know in the previous example also we have ax plus by plus c is equal to 0. if we have, this is the line given, then its slope is nothing but coefficient of A upon coefficient of B with negative sign, that is minus A upon B. So what will be slope of this line? This is nothing but minus 2 upon minus 2, coefficient of y is minus 2. So this is nothing but 1. Slope of this line is nothing but 1, and hence slope of our normal is also equal to 1. Now using slope of normal, we will go reverse. We will go in the reverse direction. In general, what we were doing, first we find the derivative, then we find value of that derivative at point of contact, then we find slope of tangent, then we find slope of normal. Here we will go in reverse direction. First we got slope of normal. Using slope of normal, we will find slope of tangent. So therefore, slope of tangent. What is the slope of tangent? What is the slope of tangent? Is nothing but again negative reciprocal of this one. And what is reciprocal of 1 is 1. So negative reciprocal is minus 1. So this is our slope of tangent. Let this is equal to m. Slope of tangent m is equal to minus 1. Okay. Now by our process, the slope of tangent is nothing but value of the derivative of y with respect to x at the point of contact. That will be our point of contact. Okay. So let us differentiate now. Now differentiate equation 1 with respect to x. Differentiate equation 1 with respect to x. What will we get here? dy by dx is equal to, remember students, this is very general function, x into log x. You may keep this value in your mind always, derivative of this function. So it is typical one. You will find this in many of the examples in various steps, in different steps. Okay. So I will find the derivative by u into v rule here. You may find it directly for CET examples, for JEE examples. You may write it directly. Keep it in your mind, fix. Here we will find it by u into v rule. So u is x and v is log of x for me. Therefore dy by dx, u first function. What is the formula? What is the formula? If y is equal to u into v, then dy by dx is equal to what? U into dv by dx plus v into du by dx. Got it? This formula I have to use here. So here it will be x into derivative of log of x. What is derivative of log of x? Is 1 upon x plus second function log of x into derivative of x, and derivative of x is nothing but 1. So this is our dy by dx, and that will give me the slope of the tangent here. Okay, we have to find the points of the coordinates of that point, for at which the tangent is, normal is parallel to this line, to this curve. Okay, so this slope at that typical point is equal to minus 1. I will put this value. Therefore at point of contact, what will happen? This value will be minus 1. This is nothing but slope of tangent. So x cancel. Here it will be 1. Therefore 1 plus log of x into 1 is log of x is equal to minus 1. Therefore log of x is equal to this minus 1, and this will be again on right hand side will be minus 1. It will be minus 2. Hence by definition of log of x, do you know the definition of log of x? Yes, what is the definition of log x? You will use that definition, and here you will get x is equal to e raised to minus 2. X is equal to e raised to minus 2 is the value of x. means I have x coordinate of that point, and using this x coordinate I will put this value in equation 1 so that I can find the value of y, and therefore to find the value of y I will put this value in equation 1. Y is equal to e raised to minus 2 value of x into log of e raised to minus 2. So this is equal to, if you know the rules of logarithm, this is nothing but minus 2 times log of e. And what is value of log of e? In our mathematics, we are taking logarithm to the base e. Remember, in physics you are taking it as 10. In physics you are taking the base for the logarithm 10 to find the log from your log tables. But here our base for logarithm is e. So this one will be minus 2 times log of e, and log of e is equal to 1. So minus 2 into e raised to minus 2. This is your value of y. So what are the coordinates of that point where the normal is parallel to the line given? The points are, therefore the coordinates are x is equal to e raised to minus 2 and y is equal to 2 times e raised to minus 2. I will write here the answer, that coordinates are e raised to minus 2 and minus 2 times e raised to minus 2. These are the coordinates of that required point. Here the answer is, I don't have much space here, so the answer is written there, e raised to minus 2, comma minus 2 into e raised to minus 2. These are nothing but coordinates of that required point.